Do diodes really pass audio? Let's find out. Good morning, YouTube. It is 10:33 now in the morning. I here with you on the bench again, or at the bench, whichever you prefer. I tore apart my Heathkit probe. As you can see, it's just tore apart. And here's the actual circuit from it. This is for Bill. I was looking into the. I wanted to see what these are. These are threaded holes here for your switch, and this is how they do it on the Heathkit. They just make a little circuit board and solder the switch directly to that. And of course, now this is a little bit bigger, I think, inside diameter than what you're messing with there, Bill, on that 3/4 inch copper. I'm not really sure, but I think it is. Let's just take a look at it and see what kind of size we are talking about here. So there, yeah, you can see that's a little bit bigger. It's a little over 3/4 on the inside. So, like I said, that's that. Like I said, this is a way. Now, a miniature switch like this would be probably perfect for what your situation is, but you really need to get these kind with the threaded holes, though. That's the whole thing behind that, and or my way of thinking, because there's just no way of getting a nut on that thing and to hold it on there. And you can screw the screws in pretty easy, but it's a little difficult to do the other. Now, the reason I tore this apart is because the ground came off of this. It's been off for a good while, and I've just been kind of using clip leads to get it back together. So I'm gonna fix this. I don't know if I'm gonna try to fix it like this, but I'm definitely gonna do something here to get it fixed and back in shape, so I will be able to use it again. I'm not sure exactly why this is all like this, but it is. And I basically don't want to do a lot of difference to this. I want to take this sandpaper and try to get some of the corrosion off there if I can, and make sure I got a nice shiny spot to solder to. And then once I do that, then I can do the others to the same thing to this piece here, and get it together, and it should be alright. But I'm going to cut this thing off. I don't know exactly why that's there, but anywho, that's what I'm doing. As soon as I get this done, then I'm going to take and look at some effects of this thing working with a DC, or not DC, but audio circuit. Bill seems to think that audio can't pass through that diode, but it does. And there is the diode right there. The way the switch works, when it's in the AF position, the probe comes in here, the signal comes in here. This is the AF position up here. It bypasses the diode, goes directly to the cable, or to the actually a capacitor here, it looks like, and then goes to the or maybe it goes directly to it, I can't remember. There's the top side of it. So anyway, that goes in there, and then the other way, when it's switched the other way, it goes through the signal comes in here and goes through the diode. Now, this is just looks like a 1N34A type diode, signal diode. So we're going to see what the effect is, and I don't think that you're going to be exactly thrilled with the because it does pass audio. There's that. Why in the world wouldn't a diode pass audio? It will distort it, no doubt about it. Because if you think about a diode, Bill, it basically takes the AC coming in and clips it in half, basically, and you get a pulsed DC out of it, and it's still going to be passed as an audio signal, and it just changes the tone of it, or the quality of it, I guess is a better way to put it. And I think the whole reason for the RF AF switch is for AF. You got to remember that a lot of these were used to work on high fidelity audio amplifiers, and you don't want a really crappy signal, audio signal coming through the RF, because it distorts it so bad. I mean, that's not going to help you with your AF diagnosis on that amplifier. So you want, that's why the switch, that's why you switch it to AF. That way you get the pure AF coming through, and you can better tell what kind of signal you're actually getting out of your amplifier. So I think that's the whole thing behind the switch. I think a lot of people think it's to do the RF, but for radios, probably you're not worried about the quality of the AF signal. You could leave it in RF, and it, just you can do that as well as you can in AF. I mean, as far as just getting the signal through. So anyway, let me get this thing fixed, and we'll come back. All right, I have the probe repaired. It is working fine now. As you can see on the oscilloscope, I have a 1000 hertz tone being generated on the, actually I'm using my phone. So basically that's what that's going to look like if we don't do anything to it. That's just directly into the AF with the probe set to AF. Let me show you that. AF. Now what happens when we switch it to RF? Now again, this is a pure 1000 hertz tone. Now I don't have the after effects of this because I don't have any way of putting the scope in line, but I'm going to switch it. You're going to hear the difference. There is no difference. And we're going to prove that a little bit differently too. We're going to use a diode to do this. And let me put that in line, and we'll bring you right back. Alright, now you can see the diode is in fact in line. If you listen to the sound, it is distorted, but it is passing it. And this is what it looks like on the scope. Yeah, that's pretty much a mess. But like I said, it is passing a signal. So, that's just what I was trying to prove. Let's see what happens when we reverse the diode. Not a lot, really. The sound's the same. I think we got a different, I think our pattern moved from the top to the bottom. That's basically what it's doing, is you're cutting off, it's rectifying the audio, or the, it's rectifying the audio into a pulsed type DC signal, and it, like I said, it does pass, but, it just doesn't pass cleanly. And again, like I said, that's what the AF switch is for. So that you get a nice clean sine wave when you put it on AF, so you can troubleshoot the audio portion of any circuit you're working on. You can't very well get a good quality signal out of, if you don't get a good quality signal out, then you know there's a problem. Like I said, if it was on RF, you couldn't tell that because you hear this, and that's just unacceptable for troubleshooting on AF. Now on a radio circuit, that wouldn't, you could hear it, and you would know there is something there. Again, not perfect situation, but it would work. Now I'm going to do the I'm going to switch over to the again to the straight through to the probe, and we'll switch it. In fact, we're in RF now. Let's try AF. Now that's directly through to AF on the probe. Let's see if we can stretch it out a little bit. You're not seeing too good of a... There it is. Okay, there's what our audio signal looks like on the scope. And again, that's not perfect. It is a signal though, so you can see it. Like I say, it does pass the. It does pass it. It's going through the diode, just as I said, and the probe or the signal tracer is on AF, and but like I said, it's going through the diode. Let me show you again. You can see it is going through the diode right here. Goes over to. Let me back it up a little bit. Over to the input of the probe right here, and that comes from the phone, the red ding there. So, like I said, it's just distorted. So it would work for troubleshooting at radio circuits, obviously. So obviously, with the out of line, you get a much better, cleaner signal. And you know, you can look at it back on the scope again. It's perfect. So that's why you want your AF and RF switch in there, and that's my feeling on it, on exactly why we do that. So we're going to switch over to the other probe here and see how it works. Get an idea of what you're listening at. Let me switch over and I'll bring you right back. Alright, now you can see we have switched over to the BDST probe, and you can hear the signal. It's nice and clear. We'll take a look at the scope. Basically the same waveform we had before. Not much difference. Might be a little bit difference in amplitude, is lower amplitude. But you can see the auto probe does basically the same thing as the straight through audio on the Heathkit probe, and so that works out rather well, I think. So we're happy about that, and like I said, that's what we were looking for, is basically something that would go either way, and we've already shown yesterday how it works with RF type of signal, so I think that should prove it to you. That I think this is the way to go. It's a simple circuit, really, no switch involved, and I think we may market this. I don't know if it'll be in this type of. We're still experimenting. I know Bill thinks that we're crazy for doing this. Trust me, Bill, we're not crazy. We may be nuts, but we're not crazy. Alright, I think this has went on long enough. I think I proved my point here. Again, let me just show you that. Let me put it over to the back through the diode, and we'll hear the difference. You have to. There you can hear audio coming through. So that is an audio sine wave, 1,000 hertz, and so like I said, it does come through a diode. So, but not as clear as this. So there's your answer on that. It doesn't actually block it, but it does change the characteristics of it a great deal. So that's what we're after to see. But this probe, like I said, doesn't affect the quality of the audio at all. So we're happy about that. Like I said, this is the way to go for us. Bill, you're doing whatever you want to do. That's fine. But you can see this probe works fine with the Heathkit. That's what I'm using it with. I'm not using the BDST today. I've got that hum. Bob seems to think that hum is coming is a miswiring somewhere. So I'm going to be looking at my BDST. I put it together pretty quick, so I could have messed up something. So like I said, that's what we're looking at right now, and we're happy with the results. So you guys have a pleasant day. Thank you so much for watching, and we will see ya.